Let's start by creating a new assembly in Siemens NX. A version of Siemens NX which I am using is 2412, so Siemens NX 2412. But this tutorial will also work for newer versions or different versions if you would like. But now I'm going to create a new assembly, Siemens NX, name it gear assembly and put it in one of my folders on my PC. Click on OK. This will create a fresh new assembly for you to import models, parts, and to assemble them. For gear assembly, we are going to go and add a component in our assembly. That's going to be our gear. And let's search the gear. This is the gear here. I'm going to select it and place that gear somewhere else here. That's our gear. Click on OK. I do not want to create a fixed constraint to this gear, so I'll click on no. Add the gear again. Now you can add different gears. I'm for this tutorial going to add the same gear, as you can see, with same teeth and same radius, same module. For different gears it will be a bit different where you have to choose the ratios, but for the simple tutorial of gear assembly I'm going to select two simple gears. Now I'm going to add the shafts to this assembly, because in most of the tutorials they do not show that the shafts also rotate with the gears. The shafts are not fixed or constrained. So for this case I'm going to add shafts which will be attached to the gear and they are going to rotate all together. So let's add a different shaft this time. Let's add the small shaft and place it somewhere here. As you can see, I've added two gears and there are two shafts which will be aligned respectively to each other, and when I move one gear they have to rotate together, all the shafts and all the gears. So that is the objective which I'm trying to achieve here. So let's start it. I'm going to go first into joints and couplers and create on hinge, create a hinge. And for those who are new, I'm going to explain how to create a hinge. So for creating a hinge between two objects, you have to first select an edge of the first object. So for example, I want to select a gear. So I'm going to select the edge, the inner edge of this gear, and going to quick pick and select the edge, and it will create a vector pointing downwards. You can obviously select the direction, but it always creates a vector perpendicular to the plane of the edge you selected, this one, and that is a vector. For selecting a point on that vector you have to select again the edge, and it will create a select the point on that vector perpendicular to the plane of the edge. Now the point which you are selecting has to be on the geometry which you are trying to constrain. It cannot be a point on a different geometry. If you want a point which is far away somewhere, you either have to use cylindrical constraint instead of the hinge, or you have to reference a point in the sketch of a model and then change the reference set so that you can choose that point and you can align your model geometry to that point. But for now, for these tutorials, for the simple hinge, I'm going to use the same point. For the second object, I'm going to choose the shaft. I'm going to choose the edge of this shaft here, and then for the point I'm going to select the same, and as you can see the gear comes in and slots into the shaft properly, and click on OK. Okay, by the way, before clicking on OK, you have to make sure that you do not click any of these things or set any of the angles in the values here, because if you set any of this, then the gears will be stuck or constrained to whatever angle you have mentioned, whatever upper or lower limit, and after finishing your assembly you wouldn't know what is stuck while you start to move your parts. You do not want that to happen, otherwise debugging the entire assembly is going to take a long time. So make sure you do not put any values in here unless and until you are really sure about what values you are putting. For now, just click on OK and that should be fine. So as you can see, this gear is constrained to this shaft. I can select this gear and try to rotate it and it will rotate the shaft and vice versa. That's how it is, and this is constraint. So that's how you create the hinge. You can go in the gear assembly, your part assembly navigator, and you can see the constraint, the hinge you have created, and you can double click on it, select it again, and change the orientation. So I want to orient this in this way with my gear pointing in the downward direction and axis of the second object, which is the shaft, pointing the upward direction. So that's what I changed going back into the assembly. After doing that, you're going to go ahead and take a second hinge here and do the same thing for the second gear. So select this, select the same edge, that is done. For the shaft, select this edge, select this edge. So this is gonna slot in there. Make sure you do not select anything, align, you can align it here as well. So I'm gonna try to align however I like. So I want to align it this way. The shaft is this and this shaft is that angle upward. So I'm gonna just click on OK here for now. As you can see, this gears and the shafts are not even in contact with each other. They are at a distance apart from each other. They have some distance in between and they are not even on the same plane. Like you can see, like this one is an offset here downwards and this is above that gear, but it doesn't matter. You can just go ahead and add a gear, select the first hinge, the second hinge. The ratio again is going to be 1 for my case because my gears are of the same teeth and of the same radius. Your gears are of different teeth and different radius, then of course you have to divide them and add the gear ratio here. You can calculate. It's an easy calculation. It's not long at all. It's not difficult. But for simplicity, I'm just going to keep it 1. Click on OK. And there you have it. This is the simple gear assembly in Siemens NX. And you can select a gear. Try to see if it moves the other gear. Now the thing is, as you can see, if I rotate this gear, it is moving the second gear, but it is moving in the same direction, which I don't want. It looks like a belt or a cam drive, which I do not want. I want the gears to be moving in the opposite direction. Also, the second thing which you notice that my shafts are not rotating with each other, even though I have put a hinge to it. So they are not rotating. And the third thing which I want to tell is that if I select the point again, it will start to rotate something else because it cannot decide what is it going to rotate, because it does not rotate everything together. Even if I have constrained everything together, like the hinge is connected to one shaft and the gear, the other hinge is connected to one shaft and the other gear, and both of those things are connected with gear, and yet all of those things do not rotate or move together. This is a problem which, first of all, you will come across when you are doing such things. So let's solve those problems one by one. The first problem which I want to solve is the gear rotation direction. So let's try to solve that. What I will do is reverse the direction of rotation here. Click on OK on the second hinge and try to see if this has solved that rotation problem. So again, this is not going to allow me to rotate anything here because it doesn't know what to rotate. So what I'm going to do is constrain my shafts as fixed. So I will fix my shafts so they will never rotate or they will never move. So they are fully fixed. They cannot be rotated or they cannot be moved. So now I will see if something changes. Yes, that solves the problem. So my rotational direction has been fixed when I reverse the direction in the hinge, and also my gears are now always rotating regardless of what I choose. Like if I choose the point again and again, it will rotate the same way and the same direction, and they are rotating in the opposite direction. So two of my problems are solved by fixing the shafts and by reversing the direction. So this is what you need to know. And again, I can go on to the second gear and try to rotate this gear, and you will see that it also does the same thing. So this is retroactively rotating each other. That's how it should function. And again, it doesn't matter if there is a distance between them. It doesn't matter at all at what angle they are. Like this, they could be this gear could be 10 miles apart from this gear, and it won't matter. It will still rotate because it couples the gears together regardless of the distance. The only problem now is that, as you can see, my shafts are not rotating because remember I've fixed those shafts here. So my shafts do not rotate, and that's a problem. So how do I solve this problem? So to solve this problem, I would need to have certain amount of other geometries which I can assign them as fixed at their particular axes. So to explain it in simple words, I will add two more parts to each of the axes and constrain them to the gears. So let's add those components. And the components are basically, one of them is my motor, which is going to power my first gear. And the second one is going to be a ball bearing, which is going to constrain my second gear. So there they are. Now they're randomly placed, so I will try to align them so that you have a sense of visual here and what is going on. So let's try to align this properly to show you where I want them to be aligned. So this is going to be aligned here, and it's going to touch, and this is going to align on this face. Okay, and I can just delete them because I only use the constraint to align. Sometimes you can use the constraint to just align certain parts and then delete them, because that's the most efficient way to align certain part which has landed somewhere else. I mean, there are different ways where you can import them with attach feature, and they will not be flying around anywhere you want. But I just like to do this like this. And now, as you can see, these things are now here. So I have a motor which is a singular part. It doesn't have any assembly in them. And I have a ball bearing which also is a single standard part. So these two parts are standard. So what I will do is, instead of fixing the shafts, I will fix the new parts which I've attached. So let's fix the motor. Now everyone knows that the motor and the ball bearing are not fixed part. They move internally, their shafts. But since this is a single part, the motor and the ball bearing, I'm gonna assume that they are a single part and fix them. So there we go. Now they are fixed. And what I will do is, I will just create a new hinge, but instead of new hinge and gear, I will just move on to cylindrical because it makes the job easier, as you will see. With the cylindrical constraint, you have the advantage of giving distance values now. As you can see that in the hinge, you do not have any distance values. So between the points, you cannot add any distance. So that is the main advantage of cylindrical constraint. That is why I'm going for the cylindrical constraint here, because I want to have certain distance between the gear and the fixed part which I have here. So let's select the gear first. To be here, that I have to be careful that I'm selecting the gear. This is the gear in the reverse direction. Specify the point of the gear. There it is. Now the most important thing, for the second object, I'm not going to touch the shaft at all. I'm just going to ignore the shaft. It does not exist for me now. I am going to select the edge of the fixed part which I imported, which is my motor. So I'm just gonna select the edge of my motor, and that is the edge. that is the vector there. Select it again, select the point there, and maybe change the orientation a bit and click on OK. As you can see here, the distance has been automatically set and calculated by the program, because I do not want these points to be at the same. If I would have gone for the hinge, then these points would be the same. It will just try to coincide this point, and which I really don't want. I want the distance, I want there to be a distance. I can even select this and change my distance to whatever I want, but for now let's keep it like this. Let's keep it at default. So I have my cylindrical gear constraint, the first one. I'll do the second one quickly. Select the second gear's edge. Be careful here that I'm selecting the edge of the second gear, the correct edge. And you have to be careful on what edges you select, otherwise the wrong edge will let you fly your object or your model to somewhere else and you wouldn't find it and you have to undo it. You don't want that hassle. So the best way is to select whatever you are doing at first properly. So the second object is obviously going to be my fixed object, the ball bearing, of which I'm going to choose the edge, that edge, and the edge again. See where the point is. That looks good. So my vector is, my gear is here, the vector of the gear, and my fixed geometry constraints vector is there. So that has been fixed. Click OK. There is some distance here, but that is whatever for now. I think I have to select here, and that should be okay. So I've done nothing else than moving on to the cylindrical constraint instead of the hinge one. I'll go ahead and just select the gear one, select the first cylindrical, the second one, the ratio 1, angle offset doesn't matter for now, and click on OK. So there has been a gear. Yeah, there has been a gear now. There is a gear now, and we'll see if the same effect happens. Like if I move one gear, it rotates the other one. And again, this is moving, the gears are moving in one direction. So all I have to do is reverse the direction of the gear. And something moved there, so I hope this works. Still moving in the same direction, so I might have moved differently. So again, and try to align this, the directions. So now after reversing the direction of one gear, the rotation direction is proper. As you can see, if I move one gear, the other gear rotates in the opposite direction as it should be, and that is how it should be done. But still, my problem is my shafts are rotating. As you can see that if I rotate my gears, my shafts do not yet rotate. What do we do about it? I mean, the best thing is just to constrain them to the gears so that they will rotate with them. So what I will do is create bond constraint objects together so that they move as a rigid set. So I'm gonna bond together the shaft and the gear so that they move and behave as one object. Bonding is basically bonding. Yeah, two objects become one and they move and do same thing like twins. So we are going to select two objects here, gear 1 and the shaft, and okay, and create a second bond of gear and shaft. Let me create the bond again so I can be sure of how this works. So let's select the gear and the shaft here. And let's select the other gear and the shaft. Click on OK. And this should actually make the gears rotate with each other in the opposite direction along with their shafts. So that's how you solve the gear assembly problem in which your shaft do not rotate or things do not properly rotate with each other or nothing rotates. But now as you can see with this set of constraints, everything moves as it should. The only thing left is to align the entire assembly properly such that it looks like connected and working together. So I'm just gonna do that without talking much because that is the most easy part. But again, I will have to remove the bondings, keep the gears and the cylindrical same, and fix this so that I can move things around and maybe try to give an offset here. So let's try to move this part downwards so I can strengthen this with touch. So after aligning the gears and giving them some offset to the shaft by using the other constraints, I'm going to enable the fix and the bondings again so that they cannot move again with respect to the geometry, and everything is fixed now. So nothing moves, and I can select and try to move something and it will not move because everything is fixed. So that's how you constrain the entire gear assembly. And if I now select anything in there and try to move, it will move properly. I have also aligned the gears teeth such that they look like they are meshing together and forming a good contact with each other so that the gears can rotate, and that looks good. You can also go ahead and add a third gear if you would like, and let's say you can just add this, click on OK, try to align their axis. So let's go this and let's use this axis, align shaft. There you go. And then want to reverse the direction, do not. And now I want to attach this gear to this gear assembly. So I can try to move this thing where I want. Just doing this visually, see how it looks. And again, I can constrain this. So let's try to fix this object and then create another cylindrical constraint by using gear edge. And shaft edge. So now I have added another cylindrical, and I can create another gear of connecting this to this, some angle and some here. And now I've connected another gear to this assembly. And if I try to move the shaft here, for example, it will all move together. Again, this is moving in the opposite direction, so I have to fix that as well for the reverse direction, and that should fix fully. Yep, that fixes the gear assembly, and now everything works properly. The shaft on the third gear is obviously fixed, but then for it to be not be fixed, you have to go again, add a different component, set it fixed, and then constrain it with the gear with a cylindrical constraint, and then try to add a gear to the other gear so that it rotates. But this is how a gear assembly works, and that's about it. Thanks for watching. I'll see you guys later. Have fun.